All right. Solving quadratic equations using the zero product property. We've been doing a lot of factoring, and now we're going to start to see, not fully see yet, but start to see why we have been doing a lot of factoring. Like, what is the use of factoring? What's the application of factoring? And instead of seeing quadratic expressions, you're now going to start to see quadratic equations. So the most basic kind of quadratic equation would actually look just like this. I'm going to just take something that we've seen before and make it equal 0. If I have 0 equals x squared plus 2x plus 1, I now turn, we've seen something like this before. This is a quadratic expression. I now turn that into an equation. A quadratic equation is basically any equation that has an x squared, or any variable squared, but typically you'll see x squared. So quadratic equation has x squared. And it doesn't have any higher exponents than that, higher degree exponents. Like it wouldn't have x to the third, or x to the fourth, or x to the fifth. So it has x squared, and x squared is the highest exponent that you have in your equation. That's what makes it quadratic. And these are a lot, well, maybe not a lot once you see how to do it, but these are definitely harder to solve than linear equations. So with a linear equation, I would subtract 1 and then divide by the coefficient on our variable. That's not going to work here. That's not going to work because if I divide by 2, then I would have x squared over 2 plus x. And there's no way to combine the x squared and the x in an equation like this. Even though it equals 0, there's not really a way to easily just use addition and subtraction, multiplication and division to solve for x here.
Why do you really need to solve it to equal 0?
Because we want to know what x is. I mean, I could make it equal anything, right? It wouldn't really matter. But there's a reason that these are going to often equal 0. So what would x have to be for all of this to equal 0? That's the question. And the way that we solve these is to first use factoring. So the first thing I'm going to do is factor this. 0 equals, I'm going to look for factors of 1 that add up to 2, and I'll see that the factors of 1 that add up to 2 are 1 and 1. And I'm going to leave it in this form. I'm not going to write x plus 1 squared right now for a particular reason. And that reason is the zero product property. This is very important. So the zero product property says if I have two things, A times B, and they equal 0, so if A times B equals 0, then I know that either A has to equal 0 or B equals 0 or both. So this is like what we would call an inclusive or. A equals B, A equals 0, B equals 0, or both. Does that make sense? Two things multiplying together equals 0, right? So one of them has to be 0. Think about when you first learned your times tables. The 0 times tables are so easy because 0 times anything equals 0.
Yeah.
This is almost like the reverse of that. If our product equals 0, one of our factors has to be 0. A and B are factors here, right? They're two things that are multiplying together. So the application of this is that here, this is A, and this is B. we can turn this into a set of two linear equations that we can solve because of the zero product property. So, let me just check where we are. We'll just go over here. So I'm going to move this over here. I'm going to write this as A. So A is x plus 1 equals 0. Or B, which is also x plus 1 equals 0. Now in this case, you probably see right away, these are the same thing, so I'm going to get the same answer. So I can just solve one of them. Okay? So I'm just saying this factor, x plus 1, equals 0. Now all of a sudden I can solve this for x. Right? I just subtract 1 from both sides, and x equals negative 1. So x is negative 1, that's my solution.
What if these were two different things?
Yeah, so if they're two, let's do one where they're two different things. If they're two different things, you'll just have two steps at the end here. So the answer to this first problem, solving that quadratic equation, is x equals 1. Just like when we solve linear equations, right, we're going to get our answer as x equals something. Alright, let's do one that's not doesn't fall apart like that. Okay, what if we had, and there's a reason I'm doing all these as 0 equals, but we are going to do some in a second that don't have 0. So what if I had 0 equals x squared plus 7x plus 12? And the instruction is to solve this. Right? Does anyone see a way to solve it right now?
3 times 4.
Okay, so what I'm asking though is before we factor, does anyone see any way of solving that? Because sometimes you might see a way of solving it. It is possible. I don't though. So let's factor.
How would you find a way to solve this?
I'll do one like that in a second. So 0 equals, the factored form of this would be x plus 3 and x plus 4, right? So zero product property says if 0 equals one thing times another thing, then either this thing has to equal 0 or this thing has to equal 0. So in this case I'm going to get two answers. X could be either negative 3, x equals negative 3, or subtract 4 from both sides, x equals negative 4.
So that's your answer?
That's your answer.
So it could be either one of those if you solve it.
Mm-hmm. Now, really the important thing about all of this is that when I start out, my quadratic looks like this. It has 0 on one side, because the zero product property is not going to work if I don't have it equal to 0. Right? And then I started with a trinomial, which I then factored into the product of binomials. Okay? Let's do one that looks just slightly different. Just a little bit different. There's a lot of ways that this can look. What if I just had this? 16 equals x squared. Is this a quadratic equation?
No.
Yeah, because it has x squared and it doesn't have any higher variables. But in this case, I actually can see an easier way of solving this.
It's just 4.
Yeah.
Okay, how would we solve this?
So
Yeah.
it's x squared, you divide both sides with square root.
Yeah, we take the square root of both sides. Now there's a really important thing here. which I don't know if you learned this last year when you learned about taking the square root of a number. How many solutions have we been getting for a quadratic equation? Or how many solutions did we get for the last one? 2. Are there 2 solutions here?
No. Yes,
So the square root of x squared is x. So we have x equals the square root of 16. What is the square root of 16?
Oh, 4 or negative 4.
Yeah, it could be 4 or, exactly, it could be negative 4, right?
So we just have to circle both.
Yeah, so both of these would be your answer. Now, let's think about this. If I were to solve this in a different way, right? Another way of approaching this problem would be, I'm going to use the zero product property. But right now it's not equal to 0, so I need to subtract 16 from both sides. Then I would have 0 equals x squared minus 16. What is that?
Negative 4 and
This, wait, what is this though? You're,
it's the zero product property.
okay, this will be the zero product property, but what is this side? X squared minus 16, your brain should be
It's
going.
a quadratic equation.
different squares.
Difference of squares. Difference of squares. And this is, there's some really cool stuff here. Like, the reason they call this a difference of squares is because it is literally the difference, right? Subtracting these 2 squares. And so if we were to solve this with the zero product property, we'd have 0 equals x plus 4 or x minus 4. So x plus 4 equals 0. Or, I'll write it like this time, x minus 4 equals 0. Let me make sure I'm still on the screen. I am. Subtract 4 from both sides, x would equal negative 4. Or, add 4 to both sides, x would equal positive.
That seems like a lot more work though.
That's definitely a lot more work, right? Definitely more work to do it this way.
Wouldn't negative
Oh wait.
So taking the square root is certainly a faster way of solving this, but either way you solve it, you will get the same answer.
and sometimes it might not be a perfect square root.
That's right. Yeah.
So
If
you
it
have
weren't a
to-
perfect square root, but if it weren't a perfect square, you also wouldn't be able to do this very easily. So
But the only reason we're trying to figure out that x equals 4 or x equals negative 4 is because it says solve. But if it just says a factor, you would have to.
well, so factor is really only used with an expression. I can't really factor an equation. I can only factor this part of the equation, right?
Right, but like you can't factor the 16 minus x.
I can factor. I could
mean,
factor
the
x
first
squared
part.
minus 16.
First part, you can't.
Yeah,
factor.
you can't really factor this. I mean, you can. I can factor 16 if I wanted to. It's like 4 times 4 or whatever, right? 2 times 2 times 2 times 2 times 2. Or factors of x squared are x times x. So you technically can factor that, but it's not really very helpful. The whole reason factoring was helpful is because it allows us to use the zero product property. Okay? Alright. What if we have something a little bit different? So we have 2 examples left to do. It's really important that you guys write these both down, because they're a little different. What if I had something like this? 2x minus 5 times 7x plus 3 equals 0. And the instruction is still solve. Can you solve that?
Yeah.
Yeah, in fact,
Foil it.
this is already in factored form. We could FOIL it if we wanted to. Would that be helpful though?
No, but good.
Not really, because this is A and this is B. I already have my 2 factors.
So you just gotta solve them.
So I just have to solve these. If A times B equals 0, then either A equals 0 or B equals 0. right? 2x minus 5 equals 0, or 7x plus 3 equals 0. Now these, the reason I wanted to do an example like this, these are a little bit more complicated to solve.
So it would be 2x equals 5, right?
So this would be, yeah, I would add 5 to both sides,
And then
2x equals 5, and then what?
x equals, and then you divide by 2.
Divide by 2,
And
so
then
x would be
x equals 2.
5 halves, right?
Can you also do 2.5?
5 tooths.
5 2. Can you also
Yeah,
do
if
a
you
lot of
wanted to write
baking,
that as
Phoebe.
2.5, that would be fine.
That's a lot of
So we
baking.
have to do the same two steps here. Basically, we subtract 3 from both sides. 7x equals negative 3. And then we divide both sides by 7. So x would equal negative 3/7. And remember, you can write the negative wherever you want. Maybe write it out. Negative 3/7. Negative 3 over 7. You could even
I
write
would
3 over
write
negative
or.
7 if you wanted.
Or in between them and then circle.
And then we could write. So these are our answers here.
Beautiful circling.
If you have a number in front of x, right, you have to divide that off at some point to solve. And so because of that, you will often get fractions as answers for these. It is possible that like your fraction would cancel, but if you think about that, and maybe I don't really want to do an example, but if I had a number that would cancel, I could have factored that out as the greatest common factor. And so that's why if I have a number in front of x, chances are I should end with a fraction, unless I missed a greatest common factor somewhere.
Is that all we're going to be doing?
Nope, one more example. Last example would be something like this. 2x squared minus 4x equals 0. So it equals 0, which is great.
So you just got to do
To
the
factor
H
this.
thing.
Can you also divide both sides by 2?
Okay,
No,
yeah,
it
good.
would- it's
So
difference of
one thing I
squares.
can definitely do is divide both sides by 2, because 0 divided by 2 is still 0. So that's going to cancel, leaving 2. So now I have x squared minus 2x equals 0.
Difference of squares.
Not a difference of squares because this has an x in it. So remember when we had two terms and one of them had an x and the other one was an x squared? You remember how we factored those?
Lee, before you go on,
told us to do is you have to put the 2 on the outside so you don't forget.
oh no, you divide
Except,
by 2.
yeah, and so this is the case, right, where I pulled out the 2 but I actually divided it off. And this is where that greatest common factor thing becomes so much more useful. It was kind of annoying, right, before, when you had to like leave your 2 over here and factor and then forget the 2 at the time. Now we just get rid of it because we have this equals 0. 2 is
Kick it
gone.
out the window.
Boom. We got rid of it. So if 2x squared minus 4x equals 0, then x squared minus 2x
There are
equals
2
0.
terms that
So we have to, the way that we factored these is by pulling out the greatest common factor. What's the greatest common factor between x squared and 2x?
X.
Yeah, x. So my factors are x, and what's left?
X minus
2.
Okay. So now this is A, and this is B.
Oh. So
Right.
either X.
So either x equals 0, which is done,
Yay.
or x minus 2 equals 0 when we just add 2 to both sides. And you get x equals 2. So x equals 0 or x equals 2.
Yay.
Okay?
I love your circles, Nate. They're great. Lovely.
That's kind of it's almost like a speech bubble type of a circle. Alright. So that is how we solve quadratics using the zero product property. Important things to remember. Must equal 0. Right? Quadratic means that we have x squared, but not x to the third, x to the fourth, etc. And then you have to remember all the different factoring strategies, right? Factoring strategies. Difference of squares, pulling out the greatest common factor, that reverse FOIL thing, etc. And we're going to add to these. We'll be adding to these now. All right.
Can we work on our homework?
Let's turn this off. You guys have questions?